This is homework example from 2B for 143's class, problem number 12. So a particular dam holds this many, let's see, that's millions, billions, trillions, quadrillions cubic feet of water, right? There's a week-long flood. The water was released at a rate of this many cubic feet per second. All right, how much water was released during the flood? So we're releasing 24,800 cubic feet for every second. All right, now we're doing that for a week. So we need to come up with the number of basically seconds in a week. So 1 second, I'm going to do seconds per minute, and then we're going to do minutes per hour, and then we're going to do hours in a day, and then finally we'll do days in a week. And again, because of the cancellation of the units that are offset, numerator and denominator, what are we going to end up with but cubic feet per week? Alright, and that'll be our whole answer. Alright, so there are 60 seconds in a minute. There's 60 minutes in an hour. There are 24 hours in a day. And there are 7 days in a week. Notice everything on the bottom here is ones. So that means all we're going to do is multiply to get this cubic feet in a week. And I probably need a little bit more room than that. Alright, let's multiply that. Alright, so there's what was released during the flood. Alright, now that is in scientific notation, which means that decimal point is actually 10 places to the right, and they're going to expect you to write this in scientific notation. In standard notation. So 149904, and because we need to go 10 places to the right, and so far we've just gone 1, 2, 3, 4, 5, 6. We need 4 more zeros after this. So 1, 2, 3, 4. So this is how many. There's how many cubic feet were released in 1 week. All right, and then part B says what percentage of the dam was released. So it's just this part. Alright, it's the amount that was released over the total amount that was in there, and then technically it's times 100% to make it into a percentage. So if I take that amount, again it's the last thing that was in my calculator, I can divide by 1 and just type in the number 600 and then just count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 more zeros after that first 1600 that you type in, and then multiply that by 100. So 0.9374%. Alright, not even a whole percentage point. So as big as that number was that we got by doing that, this number is still much, much larger. Alright, and then there's both of those questions correctly. Alright, there's that number. Notice it's not written in scientific notation, so make sure that you do expand it out. Alright, then this will be a drop-down question. You have to know your units, okay? So, it's cubic feet. There's the week-long flood, so you don't have to put cubic feet per week because there it says week-long. And then there's, they rounded it to the nearest hundredth. So, they rounded it right there. Alright, and then this is number 14 from the homework. So what they're wanting to do here is come up with how much energy this plant can produce each month. So it tells us it can generate 1.2 gigawatts, which is 1 billion watts of power should say there per month. And then it tells us how much a kilogram of coal is for the second part. So how much energy in kilowatt hours can this plant produce? Well, it can produce 1.2 billion watts. Okay, and then to convert that, there are 1,000 watts in 1 kilowatt. Alright, so if we divide 1.2 billion by 1,000, we end up with 1.2 million kilowatts. Alright, so a billion is 1,000 million, so if we divide billion by 1,000, we get millions. Alright, but our units cancel. That's the thing I want you to see here. Watts cancels with watts, and we're left with kilowatts. Now, a kilowatt hour is kilowatts times hours, so we need to also come up with how many hours there are in a month. So we're starting off with a month, and then if we assume there are 30 days in a month, it's right sometimes, it's one less, sometimes it's two more sometimes, but it's pretty close to 30 days, so we can use that as an approximation. So 1 month has 30 days. Now that cancels completely. And then each day there are 24 hours. Notice every time I bring in a new unit, the old unit that I want to get rid of gets down to the denominator to cancel. So 30 times 24 is 720. There's 720 roughly hours per month. So this is the number of kilowatts they can generate in a month. This is how many hours there are in a month. So if I multiply 1.2 million kilowatts by 720 hours, my units I end up with are kilowatt hours. Alright, so that's 864 million kilowatt hours. Alright, part B says how much coal in kilograms is needed to power this plant each month. So this says 1 kilogram of coal gives us 443 kilowatt hours of energy. We've got 864 million, so I'm going to actually write that out. 864 million kilowatt hours. Alright. In a month. Times. This tells us that 1 kilogram of coal is about 443 kilowatt hours of energy. So I'm going to put 443 kilowatt hours down here on the bottom because that'll offset with this kilowatt hours. And that's the equivalent of 1 kilogram of coal. Okay, so maybe you knew to divide, but if you didn't, the setup will show you what to do. There's a 1 down here, there's this number, there's this number and 1 up here. That means divide this by this to get your answer. So 864 million divided by the 443 is 1,950,338.6 roughly. Okay, now your homework question for this particular one will have you write that in millions, million kilograms of coal. So that would be 1.9 million, 1.950 million. So if it wants you to round it to the nearest tenth, which it does, that would be about 2.0 million. So that's where that answer is coming from. Alright, then if a typical home uses this many kilowatt hours per month, how many homes? Well, again, we take this 864 million and we divide by this number. So I can bring back the last thing I just did. Instead of dividing by 443 for the coal stuff, that's the number of kilowatt hours per home. And I get this number, which rounds to, they'll tell you to round to the nearest whole, so 851,232. Alright, and then their of those questions. 864, 2, 851, 232. So we did all of those right. So anyway, if you have any more questions, just let me know. Send me an email. Click that Ask My Instructor link, and I'll try to get you something written up.